This video is about energy cycles. So the key in the question is to identify the sign of the enthalpies that is listed in this table below. And the concept of this question is to determine enthalpy's direction of energy. So direction of energy can go either way, positive or negative. And positive, it's an endothermic reaction, and negative, it's an exothermic reaction. So there are three examples that we will analyze to determine whether it's an endothermic or exothermic reaction. So first, we have a changing of state between the states of a molecule. So if we were to go from a solid to a gas, it's an endothermic reaction. That is positive because the atoms in the molecule, it is gaining energy because it needs to increase kinetic energy to move faster and further away from each other as it moves from solid to liquid to gas. And you can see that in the physical observation as well. So solid, for example, ice is much colder than water, and that is also much colder than water vapor. And so the opposite, it's an exothermic reaction. So going from a gas to a liquid to a solid. So the atoms in the gas needs to release energy, release in the form of heat, to move slower and closer to each other to go from a gas to a liquid to a solid. So moving on to the next example, it is the removal or gaining of an electron. So here we have a remover of an electron, and that is an endothermic reaction because energy is required to be absorbed by the molecule to be able to remove this electron from its valence shell to produce a positive ion. And oppositely, it is an exothermic reaction to gain an electron because chlorine will naturally be attracted to this electron as it wants to complete its valence shell. So once it gained that electron, it will release energy. And lastly, it's a forming or breaking of a bond. So in this direction, if we were to look this direction, we have a forming of a bond. So it's an exothermic reaction because as more bonds are formed, there's a release of energy. And in the opposite direction, it's an endothermic reaction because when bonds are broken, it requires energy to break those bonds. So if we were to go back to our question, we can look at the different scenarios of each enthalpy. So first we have the enthalpy of atomization, and an example of that is changing state from a solid to a gas, for example. And since we're going from a solid to a gas, it requires energy, or there's an absorbing of energy. So it's an endothermic reaction. The sign is positive. Moving on is the enthalpy of ionization. It's the removal of an electron, so it requires energy. So it's an endothermic reaction. The sign is also positive. And then the energy of electron affinity is to gain an electron. So there's a release of energy. So it's an exothermic reaction. The sign is negative. Lattice enthalpy is when the individual ions in a lattice structure is broken. So there's a breaking of a bond. So it's an endothermic reaction, and the sign is positive. Enthalpy of hydration is when the atoms bond with water molecules. So there is a new forming of bond. So it's an exothermic reaction. So it's negative. And lastly, it's enthalpy of solution. So this really depends because we don't know, it doesn't specify what solution it is, and the solution can either be exo or endothermic. So we can just say Na or depends, or whatever the answer you want to put here. And that is the final answer for this question.